Hello and welcome to this video from Heybridge Maths Department, and today we're going to have a look at compound inequalities and we're going to represent our solutions on number lines. So here's our first inequality. Represent the inequality 5 is less than x is less than 9 on a number line. So this is 5 is less than x is less than 9. So when I just have a less than or greater than sign, rather than a less than or equal to, or a greater than or equal to sign, I'm going to draw open circles. So above the 5, I'm going to draw an open circle, and that's going to show me that 5 is not part of the set of values that satisfies that inequality. And I'm also going to do the same for 9, because 9 is not part of the set of values that satisfies that inequality. I'm just going to draw a straight line to represent them. So that now shows the inequality 5 is less than x is less than 9 on a number line. So my next question, solve the inequality 4 is less than or equal to x is less than or equal to 8. And show your solutions on a number line. So if I was to solve this inequality, so x is greater than or equal to 4, but it's also less than or equal to 8. So the numbers that could satisfy this inequality would be 4, 5, 6, 7, and 8. And as you can see here, we've got less than or equal to or greater than or equal to signs. So I'm going to draw a solid circle at 4 to show that 4 is included in the inequality. And I'm also going to draw a solid circle at 8 to show that 8 is included in the inequality. And then I'm going to join those up with a straight line. So that now represents the inequality 4 is less than or equal to x is less than or equal to 8 on a number line. Now we have a slightly more complicated example here. So we've got 9 is less than or equal to 2x plus 3 is less than or equal to 25. So what I'm going to do is I'm going to look at the left hand side of the inequality first. So I'm just going to solve 9 is less than or equal to 2x, add 3. So I'm going to subtract 3 from both sides, and that will give me 6 is less than or equal to 2x. And then I'm going to divide both sides by 2, and that will give me 3 is less than or equal to x. Now I'm going to look at the right hand side of the inequality. So now I'm going to solve the inequality 2x plus 3 is less than or equal to 25. And I'm going to go through exactly the same steps that I went through with the left hand side. So I'm going to subtract 3 from both sides. So that will give me 2x is less than or equal to 22, and then I'm going to divide both sides by 2, and that's going to give me x is less than or equal to 11. And I can now put these two inequalities together. I can write these as a compound inequality because I can see that 3 is less than or equal to x, but 11 is greater than or equal to x. So now I've got a compound inequality and I can represent this on my number line. So I'm going to draw a solid circle at 3 because I've got a less than or equal to sign there. And I'm also going to draw a solid circle at 11 because again I've got a less than or equal to sign there. And then I'm just going to draw them both up with a straight line, and that then shows the range of values that satisfies that inequality. So slightly different one now because we've got some brackets, but we're going to go through the same process again. So we'll start off with the left hand side, and we've got 12 is less than or equal to 3x plus 1. Now you've got two options here. You could expand this bracket, but because you can divide 12 by 3, it's probably easier to begin by dividing both sides by 3. And that will give you 4 is less than or equal to x plus 1. And then we're going to subtract 1 from both sides, and that will give us 3 is less than or equal to x. Now if we move across to the right hand side, so this time we're going to solve 3 bracket x plus 1 is less than or equal to 21. So the same steps that we went through on the left hand side. We're going to divide both sides by 3, and that will give us x plus 1 is less than or equal to 7. And then we're going to subtract 1 from both sides, and that will give us x is less than or equal to 6. And we can now put these two inequalities together into one compound inequality. So 3 is less than or equal to x is less than or equal to 6. And we can then represent this on our number line. And again, we used filled circles here, so solid circles, at 3 and 6 because those are included in the inequality. And then we're going to join them with a straight line. So, next question. Solve the inequality minus 9 is less than x over 4 minus 1 is less than minus 8. So again, let's start with the left hand side first. So we have minus 9 is less than x over 4 minus 1. So going to begin by adding 1 to both sides, and that will give me minus 8 is less than x over 4. Then we're going to multiply both sides by 4. So that will give me minus 32 is less than x. And then we're going to take the right hand side. So we're going to have x over 4 minus 1 is less than minus 8. So again, we're going to add 1 to both sides, and that will give me x over 4 is less than minus 7. And then we're going to multiply both sides by 4, and that will give me x is less than minus 28. And then I can combine these into one compound inequality. Minus 32 is less than x is less than minus 28. Then I can represent that on my number line, and this time, because I've just got less than or greater than signs, I'm going to use an open circle at minus 32 and an open circle at minus 28 to show that those are not included in the range of values that satisfy the inequality. And just join them up again with a straight line, and we have a representation of the solutions of that inequality. Thank you for watching.